So in this problem we have a cylindrical container that has a depth of 3 feet and a radius of 1 foot. It's filled with water to a depth of 2 feet, and we want to know how much work is done to pump the water out over the edge. So I'm going to call this delta just to make my formulas a little bit easier, and show you how we can do this with slicing. This is supposed to be cylindrical, so imagine that side being nice and straight. We know we have a radius of 1 foot and a depth of 3, or a height of 3 feet. The water has a height of 2 feet. So there's a really rough sketch of our drawing. What I like to do then is make a slice of our water. So there's my slice, and let's give it a width of, let's say, delta H for height of water. So first thing we're going to do is we are going to get the volume of that ith slice. Now it's a cylinder. One of the nice things about a cylinder is the radius is the same the whole way. So it's just going to be pi times the radius squared, and then it's got a volume because it's got a height of delta H. So pi delta H is actually the volume of the ith slice. Now we want to turn that into a force on the ith slice. All we got to do is multiply the volume by delta. So delta pi delta H. Obviously we're using the word delta two different ways here. Lastly, we need the work done on the ith slice. Well, we got to call something H. We could, if we want, we can call it the height of the water. I think that would make sense. The height of our slice, not the 2 feet. The height of the slice will vary. Now that makes the distance that the water has to go the 3 minus H. 3 because the whole tank is 3 feet. We've set this to be H, so that makes this 3 minus H. So we have delta pi delta H times 3 minus H. We'll reorder these when we write up our definite integral, which is what we're doing next. So W equals, the delta and the pi can come right out. We have 3 minus H dH, and now our limits. Well, we're integrating over the water, so the limits are only 0 to 2. What's cool is we can now see that this covers all the heights of the water because the top layer of the water only has to go out 1 foot. Well, when you put the 2 in, that's the 1 foot distance. When you put the 0 in, that's the 3 foot distance that the bottom slice has to go. Let's go ahead and evaluate this integral. It's not very difficult. I'm going to leave everything in terms of delta pi. We have 3h minus h squared over 2 from 0 to 2. When we plug the 0 in, the whole thing's going to zero out, so we're not going to worry about that. So we have delta pi 6 minus 2 squared is 4 over 2 is 2. So we get 4 delta pi, and our units here is foot-pounds.